draft physics video thingy. Science. Well, mostly physics, yes. Anyway, yes. It's the photons. Yeah, I haven't done much work on this stuff, but it's always rolling around in my head, the thinking about it, the new vision of the universe. And especially the difference between a photon and one of these quantons, gravitons, whatever. The stuff, making the stuff change its direction versus the actual collection of a fish. So you can sort of think of a photon like most of the stuff. Let's say you just can't see the other fish, but there's other fish forcing these fish into the circle. And there's an equal number of them from all directions, so it comes out to a nice perfect circle. But what a photon is one of those fish who gets collected as part of the swarm instead of just bouncing off. Instead of changing this fish's direction by coming in, hitting the fish, causing the fish to go that way, and then it goes off the other way. It actually gets absorbed and becomes part of the mass of the thing. So photons are a way of exchanging mass, in a sense, besides just directional information. But they still have their directional information. So when this swirl absorbs a fish coming from a certain direction, that direction becomes part of the net direction of this entire mechanism. It now has it doesn't go away. That directionality still exists. And that's the truth of the whole universe. Once you have a directional imbalance, momentum, you'll keep it until something gives you a different directional orientation, changes your balance. It's just so much. It'd be really nice if sometimes you just kind of like this little catch, which is the speed of these fish. And so it has to be understood that this blocking pressure would create a nice balance where you could say it would be very yin and yang. If a fish comes in this way, for it to stay in the swarm, another fish has to come in going exactly the opposite way. So they'd end up gravitationally connected. So the blocking pressure, as this fish blocked fish from coming in this direction, so to speak, caused more directional changes. Caused this fish coming in this way would end up coming out some other way. Well, theoretically, it doesn't really happen that way. It's the directionality is always there. It's just changed. This kind of in some way that makes it miss the other thing. So the point would be, though, is if a fish was coming in this way and was hitting this fish, and that would cause a negative pressure on this side, if you can just visualize that. The trick is that this distance is much shorter than this distance. Right? So this round distance is really long, and this distance is really short, and that distance is important. So obviously the fish it would be affecting would have to be it's the opposite. It would have to be something like this. So instead of having a perfect, like one going this way and one going this way, it's one going this way and one going that way, that direction, for the two to end up in the same place, to affect each other gravitationally. But the catch there is that this fish, the one that's now going to be affected by this by being altered, its gravity now wouldn't be balanced to this fish's gravity, because it would have to be up here to balance this fish's gravity. So that's where this has to work out, where there has to be a certain number of fish, at least 4, let's say, where this one's gravity will affect, like fish A's A gravity, A direction, would be affecting fish B's B direction, and vice versa. So instead of being gravitationally connected to the thing its partner, so to speak. It's connected to the other fish's partner, so it's a kind of intercourse where they each give each other half the gravity component the other needs to compensate for this distance problem, this being a shorter distance than this, which changes the timing. So anyway, it'd be really nice and simple. I'm just saying is if you could just think of this as everything in the universe is really just a matter of collecting direction. And if you really think about a circle, what is a circle? A circle is all directions, right? So you go in all directions, you know, at least in the 2 dimensions. As you go in a circle, you hit all the directions as you go around, so you have a net direction of 0. And that's sort of the power of this capturing mechanism. But that is only true if you have a high enough density of fish. If you only had 4 fish, you'd end up with a net direction. Whether you like it or not, there wouldn't be a perfect compensation. There wouldn't be one yin and a perfect yang. There would be a kind of imperfect net balance, and that's what's causing probably Brownian motion and all this other stuff. Is all this? The fact is that, you know, it's not very practical for an electron not to wobble, because its directionality, its structure is so it's not undirectional until it gains greater density. That's probably deeper into this than I wanted to go. So I just wanted to get to this idea, you know, that first understanding, you know, that light or photons, the energy we see, is just energy that's transferred. So that's the fish captured. But you have to, like, for this diagram to really represent what's going on, you have to understand that there's a bunch of fish constantly banging into these fish, and that they're not in a circle by will. So you have to think of them as not having a will to be in a circle, you know, to swim in a circle, but that it's actually these external fish that just keep pushing them into conformance to that shape. And the difference between photons or energy, the entire electromagnetic spectrum, you know, from radiation to radio waves, is that those fish are capturable because they have that frequency, they have that distance between each other, and that distance is what makes them capable of being captured. So now you can sort of understand it a little bit, where if the first fish comes in, he would go a certain distance, and then the other fish would show up. And that's what I'm sort of saying, is that, you know, ideally it would be like the first fish comes in, and the frequency for this structure would be the diameter of the circle. So, you know, the second fish would come in just as this fish was over at this other side. But that's the trick, is that it doesn't really work that way. What you have to have is a frequency balance to the electron you're coming into. So let's say this electron only had 4 fish, and so it had a slight imbalance in directionality, so it ended up moving in this direction because there's a slight imbalance in that direction. The key would be is that at a certain frequency, that directionality would be compensated for. So when fish 5 and 6 show up, which would be the photon frequency, they would fill that gap. So there would be a gravitational imbalance inside of here, and that would make it more likely for them to get stuck here. So the first photon comes in and he compensates for an imbalance that exists, and then the second one comes in, but it would still be at this, not the full circle diameter, but some measure short of that. So the frequency, the capture frequency, would be the distance from here to, say, here, and that would be the capture frequency for this particular object. Now obviously you can double that, and that's where you get into harmonics, right? That's where it gets so interesting. Because now if you double that frequency, a capture frequency, it's still a capture frequency as long as your first fish maintains and is able to be, continue to be captured. So if it comes in, let's say if it came in low, then it would take it maybe a couple of rotations before it spiraled out of the collective gravity. And so you have some time. So you could actually go 2 cycles or 3 cycles or 4 cycles of the first photon, the first piece of the photon. See, this is, our language is so broken because this old physics is wrong. A photon is 2 gravitons. And so you sort of have to understand, when I say photon, I don't mean 1 photon. I mean it's 2 photons that have a distance between them. They're traveling exactly the same trajectory, and they have a distance. That's a photon. It's 2 gravitons, 2 quantons, 2 fish. So anyway, the distance could be twice, and then that still would compensate, and you'd end up maintaining this gravitational web in terms of a net, the net directionality. So you just sort of have to understand that if you had a bunch of these fish, like you had 10 fish and they were all tending in this direction, that would be incredibly imbalanced, and there's no way for that to be held together. So you have to have, a matrix of balance, but the balance isn't 180 degrees. The balance is somewhere, 160 degrees or 150 degrees. So that's what makes it a little bit awkward. I mean, it gets into this distance problem in time is interesting because it's the same thing that, like I said, now creates this spin argument, that things have to have a rotational spin, gravitational bodies, for the gravity to actually get ahead, so to speak, of the thing it's affecting. So there has to be a way of changing where the change in the field balance has to change because the spin throws the field balance ahead of itself. So you could argue that the fish blocking here would be pushing this angle a little this direction, and that's what you need. You have to have this rotation for there to be a possibility of the gravity ending up where the object will be, kind of thing, that it's gravitationally connected to, because again, this distance problem. Gravity has to travel the speed of light, so it's not instantaneous. It's easiest to illustrate when you have 2 fish that are, instead of a center object and measuring gravity, just the understanding that if you have just 2 fish gravitationally connected, and you just understand that the blocking force is taking this direction, this straight line direction, and the force it's going to affect is moving in this circular direction. And so quite obviously this fish won't be able to be here, or this fish is the fish we're really talking about, but it won't be here because it's taking this much longer path. So the gravity will be here much quicker than the fish would get there, and therefore it wouldn't work because of that speed problem. So anyway, just obviously there's no rule that physics has to be simple. So of course it had to, there's catches, no doubt, and nuances that and there's probably reasons why the whole thing would fall apart if it didn't have that catch. But it is an annoying catch just because that just adds more complexity to the overall math of trying to figure out what the net balances are. So anyway, I just want to still get to the idea. Maybe I'll just keep using this as a drawing board. But that you have this field, all this field of fish, and that it's just changes in these balance numbers in this field. This consolidation of some sense of directionality. So like I said, this perfect circle kind of thing ends up becoming a very neutral force in terms of affecting anything. So everything, it doesn't leave a real hard signature behind, except for the fact that if something was here, it would be shaded from all the fish coming in all these directions. So all the fish hitting this way, this one would be shielded from, so there'd be a pressure to drive it into it, you know, gravity. But that's the same effect force is being applied in all directions on this one thing. And it's just all this stored directionality. And that theoretically, this, I don't want to step ahead of myself. It's all just about time and how you release things, right? So if it changes, if the release date for these fish, if we can vary it, you know, if we can control it, we could release them all at this point. So each fish just left in one direction. That's if we allowed time to pass. Now if we instantaneously release all these fish, then yeah, each one is going in a different direction. So the energy would be non-directional. So the effect on the field would be, you know, a bunch of fish going in all kinds of directions. And like I said, if I time the release, I can end up having a beam of energy, you know, going in one direction. Now, what difference that makes to the field, it doesn't, I don't know, but it's just this idea of understanding, you know, that we just start off with something, you know, balanced, something just a matrix or whatever you want to call it, just a, you know, there's nothing happening here, kind of thing, and then this big bang happens, and what it does is it just pushes all this stuff now, instead of just being tied to each other. You can almost think of these as the arrows, you know, and it just breaks all these, releases all this. So now you have this entire field of chaos. You know, I've drawn this. You've seen images of that with the arrows just in all kinds of directions. I suppose I should post those pictures on the website, and then I can use them to my at will. So anyway, just think of all those scattered lines moving in the different directions, and so that's the universe. And then what happens is these bits end up by incident end up being at exactly the right movement angle. So they interact in a circumstance where they show up to each other, they interact with each other at exactly the right angle, where now they're not going to exchange directional information purely. So like say this one's going to hit this one, and you know, this one would go this way and this one would go that way. It's an exchange, although it's invisible. I mean, you know, I've done that too. I've explained how, you know, the appearance can be that two things intersect. It could look like this bounced off that, or it could look like this just went right straight through that. So there's these two ways to look at it. But what's really happening is they are bouncing off in a pure kinetic way. So anyway, and so we have the lesser pressure here would be transferred here at the right timing moment, you know, to compensate. And this one would be at just the right spot to receive that lower pressure, and now it will tend to go more in the opposite direction because there's more pressure coming from the opposite direction. So it will have its direction changed. And then it's also affecting this one, so this one's going to have more pressure coming from this side, and so its direction is going to be changed. And the two things, as you can see, they'll just slowly but surely end up capturing each other. They'll end up circling each other based on the fact that the field, creating even pressure, is now uneven based on their association. So it's just gravity. So the nuclear force is just a form of gravity, and it's just this density thing. You know, we just can't appreciate how many layers of density the universe is. It's the same gravity, and the gravity that's affecting me now isn't affecting, I've said this before, but it's worth repeating, it's not affecting my matter, it's not affecting this, it's affecting the individual fish. It's hitting the fish, and because there's an imbalance, like say when I'm in gravity, obviously there's more gravity coming from this way than there is from this way, okay, because it's being blocked by the earth, let's say. So I'm being pushed down by the under pressure here, and the fact that there's just more fish coming down this way. So there's more fish changing directions in this direction, and so this will tend to move, but it has to move by hitting individual fish. It's a nuclear force. Gravity is a nuclear force. The same nuclear force. Gravity is, whatever you want to call that, the strong or weak force. I mean, gravity is just an expression of the very same force that's holding electrons together and protons together and neutrons together, and then collectively holding atoms together. It's all one force. And it's the only force that's transferring anything. So all forces that we call forces, all transfers of energy, sometimes have the signature of photons, or we can see the bits coming off. we can detect the gravitons. So when they're in the form of a photon, we can detect a graviton when it has a frequency, and when it's actually captured by the matter. So it's basically exchanging a real. It's not just exchanging direction, it's exchanging the body of the quanton. So it's adding a quanton to this structure. It's adding mass. The number of fish is the amount of mass. And so photons are capturable and transferable as fish, where gravitons don't get captured, but they just exchange directional information. So it is such a subtle difference. There's such a subtle difference between this and this. You don't see this looks like a dramatic difference. I mean, you can really see the difference between this and the field. But in reality, the field is just as dense with fish as this is. It's just that this has directionality, specific directionality caused by the trapping, caused by that intercourse taking place between the field effect. So it's just so, so I mean, just sort of an important thing to understand is that in this visualization we can see it so clearly because we've taken out the real force. We've taken out the force that's holding it together, and the force that's holding it together is a density of fish just as thick as this. It's just that it's undirectional. It's coming from all directions, and it's uncapturable. It's going to keep going where it's going. These graviton fish come in and go out. They don't stay. Photons go in and they stay for a while. Maybe a really long while, and then they leave. But gravitons just go in and come out. So they don't, that's the only difference. So the only difference between matter and non-matter space is the difference is only the fact that this directionality is trapped, where this directionality keeps going. Yeah, that's probably close enough. I just mean that it's just such a, it's so, to me, just thinking about it, it's just so interesting. No, it's just such a great reveal of this dynamic, and it just makes it also understandable about what's really happening. Is that this is kind of just a battery. This is just a way of storing directional information, collecting a whole bunch of it. And then the fact is that this thing this mechanism, this machine that's now created, theoretically can release fish in a specific way. And so instead of the field being just everything going in chaotic unidirections, there can be specific directions. Because time is bent, in a sense, in here. the destiny of these fishes is all just trapped in where time and distance is lost. You know, it's in a sense. That's just in a metaphorical sense. I mean, obviously it's not, but I mean, to the rest of the universe, they're in a time dilation in the sense they're not doing what they're normally doing, which is traveling distance through time. So it's sort of broken the relationship between time and distance by creating this circularity, where they just end up back where they started, back where they started, back where they started, back where they started. And they're not going anywhere anymore. So it's a kind of, it kills the chaos by creating structure. And, you know, structure is anti-chaos, essentially, a way of thinking about it. And so matter is just breaking chaos, obliging there to be some sort of consistency or conformity to this pattern. And this circular pattern, just as the way we say it's circular. Circular is circular, in the sense that circular will just consume essence. You know, and essence for a quanton would be distance, traveling from here to there. It's not allowed to go from here to there anymore. This fish will not go where it wants to go, well, where it was going. Will now just go right back to here again. It's going to go around, and it's going to end up right the fuck back here again. So it's just spinning its wheels, so to speak. And that's the difference between matter. I won't even say the word energy, because that's the wrong way to put it, but energy, you can kind of see this. Say this was an atomic or nuclear bit. You can kind of see that this is what energy is. Energy is a bunch of these quantons, and if you release them, there's energy. This is mass that you've released, and the ones we can see are the ones that have that period, the frequency between their release date. But if you release a bunch of without any, you've just released the force, essentially. They're still fish. They will still affect whatever they hit, like gravity. They're just not capturable. So now they're back to being quantons. They're back to being independent fish rather than formatted fish, or however you want to put it. But the fact that they have a directionality, and that directionality will change balances somewhere, is just a fact. So again, I've in trying to explain this, I did write up a little bit, and I just kind of pointed out that a photon travels from point A to point B. The same photon that left isn't the photon that arrives. Actually, it didn't travel from point. The photon actually got knocked in all kinds of directions and ended up going who the hell fuck knows. But the directionality it had was something that couldn't disappear. So like this, the X example, you can't change the fact. So even if this is bending this way and it's a reflection, the bottom line is this direction is always a direction. It's there, and it can't be destroyed. So this is the part of energy that cannot be created or destroyed, is the fact that the fish have a head and a tail, and they're going in a direction, and that in the end there's a balance, but you can create pockets of imbalance. So anyway, I have to make a call. Be back. Okay, I'm back. I guess I probably should just finish up, but it's this whole directional thing. I just, it's what I'm trying to get to is this idea that, that's a system, and these collections of stuff just end up being collections of direction. A net direction of their internal pluses, and minuses, so to speak, in terms of, they have so much component that's going this way, so much component that's going that way, so much component that's going that way, but it really is all additive. So, get back to the pin picture. So, yeah, it really just depends. So like I said, I could subtly edit this picture, and just take out a certain number of fish going in a certain direction, like, you know, just on this side, take out 10 fish, and you wouldn't see the difference. But the fact is there would be a difference, and this thing would move in that direction because it would have more fish going this way than had fish tending to go in that direction. So if I remove these, you know, fish in this half and just took out some fish going this way and fish going this way and fish going that way and fish going, you know, all those directions, the net would be a change in the balance in this thing of fish. So you have actually, see, these fish retain their identity. So like a fish comes in going this way, that going in this way is still in this thing, and as a reality, the fish's identity is still this until some external force, you know, some imbalance in the external world forces a change in it, changes the identity of this fish. So until he's not being pushed back and push this, you know, until as soon as there's an imbalance where he's pushed in one direction and never counterpunched in the other direction, that identity stays in this thing. So it's acquired a bit of directional information when it absorbed this fish. And again, you can sort of understand if I had 10 fish coming from this direction and only 8 fish coming from this direction, that all these fish would start getting changed over time. So if I just keep doing that, I'll just keep changing the direction of fish, and this thing will acquire that directionality. Eventually it'll absorb enough imbalances in its fish. It'll end up with more fish going this way here than fish going this way here, and it will end up having the same velocity as the force is applying its acceleration, so to speak. So the acceleration is the differential in direction. So if there's more coming this way than there are coming this way, there's an acceleration force imbalance. The imbalance is the acceleration, and the movement is just a reflection of what the consequence of that acceleration. That eventually this thing will acquire the exact imbalance that exists in the world, and this will become just as imbalanced as the force. And once it's imbalanced, even if the force goes back to balance again, this will maintain okay, its velocity. Yeah, and so what did I want to say about that? But you know, that's so I'm just trying to get to some way of describing that it's just this, it's all just additive. All the influences, let's say this was an atom, you could just figure it is a byproduct of its environment, just like we are, okay? It doesn't have any free composition. Its composition will be an exact reflection of the world that affects it. What comes in, and what comes in will have to be accounted for. It has to be, for it to be destroyed, something exactly the opposite has to come in to counterbalance. Or it will retain that piece of character, that change. But you can just think of it as just adding. You know, you can just think of it, you're just adding fish influences. You're just adding directional information. So you just have like everything, you would just give everything a total directional number, and any imbalance in that yin-yang, any imbalance in those directional numbers would be reflected in what is the identity or the movement of the overall thing. And mostly. But it gets very complicated. Like I said, you know, once you start having this school, you know, this, let's say this was a neutron, okay, then you got a proton over here, and those two are being forced into each other, forced into a relationship, and then there's an electron out here that's also changing the force dynamic, and it's all this pulling and pushing on each other, this elasticity. I guess that was another concept I sort of wanted to get to, but that's really not important right now. But it was like when you think of like the Hoover Dam, right? Tremendous water pressure. So there's a force pressure, lots of arrows trying to get out, so to speak, lots of arrow imbalance. And yet it stays balanced. And why? It's because even though it doesn't look elastic, the Hoover Dam is really elastic, and what it's doing is pushing back. It's the equal but opposite reaction thing is happening. And so as the force pushes on it, it stretches its own internal structure. The fish inside of it start stretching or changing direction, and then they exert a pressure because now they have an opposite disposition. So where they start off like in neutral direction, you gave them an opposite direction, and now they have a net imbalance. Like you didn't, it wasn't like, how to explain this? It wasn't the direction was just temporary, so to speak. Well, that's not the right way to say it. You can almost see it like a compression. If I compress this circle in a direction, you could sort of sense that it wouldn't be balanced, and it's going to force back. That the gravity's going to, the internal dynamics, going to have a necessity to get back to its balanced state. And so it's just that fight back. It's that elasticity. So you have to sort of just think that all this matter is very elastic. So even when we think of steel or cement or things being really diamond, being really hard, they're still elastic in the nuclear sense. They're still elastic as real energy structures. So they're still able to absorb and emit fish, and they're still their internal mechanism, the internal mechanism of the nuclear forces are still elastic. So even though the external appearance seems hard, internally they're just as soft, so to speak, as a bag of helium. The nuclear forces are still elastic, and that's where all this stuff is happening. So yeah, I just thought I'd throw that in there. But that's what's happening. It's just this idea that there's just this vibrating, the force is being affected. It's happening. Okay, the water, so to speak, is escaping. But the matter, stretched to a certain limit, pushes back. And just, that's all that's happening, is just that equal but opposite reaction. So as the arrows come in, arrows go out. Because they can't go, without breaking. Some structure has to be broken. Some gravity has to be denied its effect. Yeah, well, that's another whole subject to be interesting. It's just talking about the breaking point of this relationship and how much stronger the mechanism becomes as it gains more and more mass. And then there's a point where it gains perhaps an imbalance. Well, atoms get more complicated because of the electrons. So as the electrons get denser and denser, and the nucleus gets less and less significant by comparison to the electrons, that disproportionality destabilizes the atom. And that happens in the real heavy elements, the radioactive ones, is they're just constantly, atoms just break, periodically. Releasing energy, releasing the fish. So anyway, that's enough for the video. This is, this is I'm just sitting here, just saying it. This is so it as the explanation. And I got the magnetism 2 thing. That's the filtering based on polarization. Same effect though. It's gravity. It's just polarized gravity. It's just like all this. It just makes infinite sense. It explains momentum, explains why things keep moving, explains inertia, explains all of this stuff. And here I'm sitting on this, and it's like no one cares to give a damn. It's just like I'm not, I'm just saying, you'd say just incrementally that there would be smart people who'd say, yeah, I get this. Okay, yeah, this is, it's people who know something about physics, and they would do something to start rolling a ball of some kind of, yeah, this is it, this is the story, this is our reality, this is how the universe works. It explains time dilation. It gets rid of all the mumbo jumbo of bent space and nothing telling matter what to do. No, there's something telling it what to do. There's a whole big pile of a something telling it what to do. It's just that the only part that we can see is the non-chaos part. We can only see filtered pieces of the universe. We can't see the unfiltered part. But the unfiltered part is 99.99999999999% of the universe. Most of the universe isn't doing this. Most of the universe is just fish going about their business. Anyway. So, till next time. Yeah. I gotta make more physics. I gotta write. And it's just, you know. I used to be a fairly good writer. I just have lost the ability to anticipate all the stupid things people think. And I get so lost saying, well, they're not going to understand that. Oh, they're not going to understand that. Oh, they're not going to understand. You know, I have so low an opinion of you. Sorry. But I mean, yeah, people just don't get shit. They're just so stupid. I mean, somebody asked in one of the comments in the last video something like, you know, well, how does the, what holds the atom together, or something like that. It was just and you're just like, I just told you what holds it together, you fucking idiot. The whole universe is full of little fish banging into everything. That's what's holding it together. Fuck, I just explained it. And it, you know, you're just like, fuck, you just didn't get it at all. You know, you preface the statement by saying something like, oh yeah, this looks like really good, but, and the but question was just so fundamentally wrong. I mean, it's so fundamental. You're just like saying, how can you say you get it when you just missed the biggest point of it? Like, the biggest point I should have made here is that, you know, when I was talking about the fact that this is an illusion, that the entire universe is flooded with these fish. You know, the real image is there's more fish out here doing this than fish in here doing this. But this arrangement is so fucked up, it's so anti the chaos that's going on out there, that's why this sticks out. This sticks out because, not because it has more fish in it, it sticks out because it has the filter effect. It has this non-chaotic, this formatting. It's the formatting that makes it visible. The filtering, that's the right word, is the structure. Alright, anyway, enough of that. Alright, till next time.